plus what do you have? Nitrous oxide. So these four reactions, five, one more I'll tell you, with very dilute nitric acid. That also is a possibility. Here, so zinc reacts with concentrated nitric acid. What does it form? It forms zinc nitrate plus nitrogen dioxide plus. There's one very common, very odd question which is asked. What happens when zinc is treated with very dilute nitric? I think it's about 2%. If I remember, it was the man mentioned also, it is 2%. In this case, what happens? You get zinc nitrate, no doubt, but you also get ammonium nitrate. Ammonium nitrate and so this is the difference. If they ever ask you dilute and very dilute, be very careful. Okay. So this was about metals. It is clear. Whereas now there is a give reason they can ask. Give sign GSR means give scientific. Okay. When you talk of give scientific reason, what happens? We have why what do you call chromium and this fellow aluminum. Why chromium and aluminum do not react with nitric acid? Do not react with nitric acid. See what happens is they form a protective layer. They form a protective layer. They form a protective layer of oxide film, which prevents attack of nitric acid. So this can be a 12th standard question. Clear? Then when I talk about iodine, okay, please take down this. This was metal. Now we come to non-metals after. Transmission हो रहा है, क्या करें? तो धीरे को better graphic card. कल का भी we will कल का हम Okay, great. I can hear you. So now what we have, we are still on chemical properties. We come to certain non. Other than action of, when we talk of action of non-metal, this is clear. The two important ones that we are talking about is we have three. First is sulfur. Sulfur reacts with nitric acid. Okay, it forms sulfur is oxidized with sulfuric acid, NO2. The second one is iodine. This I think is very important. This would be important from the entrance exam point of view for the simple reason that iodine reacts with nitric acid. And what does it form? It forms HI, iodic acid. This, it forms iodic acid, nitrogen dioxide with phosphorus. Third one, with phosphorus concentrated nitric acid reacts to form Hg, H plus plus. So this was about non-metal. Okay. Then what happens is its role as a aqua regia. So what is aqua regia? Aqua regia is three parts, three parts of concentrated. That was pure nitric acid was aqua fortis, aqua regia. So three parts of concentrated plus one part of concentrated fuming nitric acid. So this itself is a question on its own which we'll answer. Now how does it dissolves noble metals like gold? It dissolves noble metals like gold. It dissolves noble metal like gold. So what happens in this case? How does it dissolve? The HCl reacts with nitric acid. And what does it form? It forms NOCl, nitrosyl chloride plus H2 plus nascent chlorine, highly reactive. Now this gold reacts with nascent chlorine. And what does it form? It forms AuCl3 and that reacts further with HCl to form HAuCl4. This is orochloric acid. Orochloric acid. Then what happens? How do they regenerate? I mean, I think what they do is they add urea. When they add urea, what happens is this gold can be regenerated. So when you can see some YouTube videos which are available where what they are doing is they are removing gold from all these electronic scrap. All your electronic scrap, everything has got very thin gold on it. So what they are doing is they're taking all the electronic scrap metal part, dissolving it in aqua here, and then they are, I think, removing the copper from that by adding H2S or sodium sulfide. The copper sulfide black precipitate is removed, and to the remaining one, what happens is they then add aqua regia and then add urea. When they add urea, gold gets repressed. So this is the basic idea. I mean, I have never tried it. I was always very eager to try that. But then citric acid and all these are special. And therefore, it is with risk of life. But we can't do that. Then, okay, take down this. I come to the most important point, that is round ring test. Okay, great. Now we come to, now please pay attention. This is a very, very important question. If you remember, I think discussed this even in coordination, but I'll discuss this again because this question has been asked very frequently. What is the charge of Fe in this compound? Here. So we have the brown ring. Very important. Brown ring. When you're talking of brown ring test, what happens? When you're talking of brown ring test, now see what are you doing? You are taking it is a test for nitrate. It is a brown ring test is a test for nitrate. It is a test for nitrate ion. If you remember, you have done this nitrate. I don't think you have done nitrite. Nitrate and nitrite basically very similar. If it is a nitrite OS plus freshly prepared what do you call FeSO4 and you add acetic acid, you will get a brown coloration. Whereas here you are getting a brown. Why we are checking for this is because I'll tell you, it has the application in what do you call food chemistry. See what happens, meat export. I mean, once before this government came, we were, I think, a very big exporter of meat. That is buffalo meat, all this meat. We were exporting it to Gulf, the halal meat, whatever. Now, how will they check? Now, what these butchers used to do is, if the meat becomes little old, okay, the color of the meat becomes pale white. So what they used to do is they used to rub the meat, the carcass as they say, they call it carcass, the carcass with sodium nitrite. The sodium nitrite used to react with the blood, the hemoglobin, and give a bright red color as if it is fresh. So at the port, there's always a standard what you call testing which they do. They take a small amount, a piece of meat, they add acetic acid, and they add freshly prepared ferrous sulfate. If there is a brown coloration, they know that they have added nitrite. They have added nitrite. So that inorganic test, what we are doing in our practicals, most of them don't do. That's a different thing because they don't understand the importance of that. It's a very simple thing. All my life, when we used to get water for injection water, which we used to prepare, we used to do this Nestle's reagent test every day to check whether some ammonium leakage is there. So what you are doing in your 12th has got an industrial application. So what distilled water which we prepare, we know there is nothing, but we can go through all the tests. Test for carbon dioxide, test for ammonium ion, test for lead. Here. So similarly, in meat, they test for nitrite. So similarly, we have nitrate also being tested. So how do you test for nitrate? See, we add substance, that is original solution plus concentrated. And then what happens? We add freshly prepared ferrous sulfate. Cool. So you have to cool because OS plus H2SO is a highly exothermic reaction. So what happens is, what is happening over here? The freshly prepared Fe plus 3 is reacting with the nitrate NO3 minus in acidic condition. And what does it give? It gives nitric oxide plus 3Fe plus. Now, freshly prepared ferrous sulfate basically is FeH2O6 plus 2. So, ferrous sulfate, so this is plus 2, and then what happens? You have balanced by sulfate, ferrous sulfate. So, this complex is freshly prepared. Freshly prepared is FeH2O, hexaaquo, ferric, okay, ferric 2 ion. Now this reacts with the NO, and what does it form? Fe H2O5 NO plus. Now this is a brown form. So what happens is, sometimes, now you have to understand, if you shake it violently, what happens? Shake it, not even just shake it, the brown color vanishes. Why does the brown color vanish? When you shake it, so here what happens? You have NO, nitric oxide. So what is the charge on Fe? Charge on Fe is plus 2 over here. When you shake it, what happens? NO, okay, the transference of electron, it becomes NO plus an electron. So now what happens is, this still remains the same, Fe H2O5 NO plus, and this is Fe plus. So here what happens is, you will have the charge on Fe to be equal to plus. Are you understanding? So you have to, they ask this normal question that, so from this was nitrosonium ion, this will become, this is nitrosonium ion, this is nitrosyl. NO. So here one extra charge will go over here and this will become Fe plus. So this question they asked normally, what is the charge of Fe in the brown complex? In the brown complex, it will be plus 2 because these two are neutral ion, neutral ligand. But here this will be Fe plus 1 because this is plus 1, nitrosonium. So you have to read the question carefully. If they don't say brown complex, then it's a matter of worry, then it's Fe plus 1. If they say what is the charge of Fe in the brown complex, FeH2O5NO, then it is plus 2. Take down this.